I'll start off by sharing a story. So not so long ago, my team went to a dairy company, and they had called the team because they wanted to know how we can do AI and help them. And this was the largest dairy company in India. And of course, all of us think that AI is something everyone understands, and so we were happy that even a dairy company was looking at AI. And so we went there, the team went there, I was not there, and they had a discussion, a pre-discussion, and they were taken to where the cattle were being reared. And so the question the engineer there asked was, look, this is our cattle, and we use AI here. Tell us, how do you use AI? Somebody is already getting it. So after some discussion, my team members found out that whereas we were talking about artificial intelligence, the other side, they were talking about artificial insemination. So it's better to always clarify which AI you're talking about. So happy to start off talking about engineering and engineers. And before I start, the past president, Bob Tran, couldn't be here today, but I want to acknowledge the wonderful role he played in thinking about engineering and engineers and focusing on mentoring. And that's something that we will continue into the future. The role of the president of IET is 1 year. IET has been around for 150 years. So we provide that continuum through the many terms of many presidents as we represent all of you, the members, and that's how you should think about it. And I'm also very happy that today, many of my past colleagues, the past presidents are here. Peter Bonfield is here. Mike Carr is here. Robin Saxby, Sir Robin Saxby is here. So ladies and gentlemen, if you can join me in welcoming them as well as all of you. So talking about engineers, again, I'll tell you a story. There was a problem which came to me, and the problem was such that I took one of my engineers to the problem. So the way I always think about the best solution coming out of a situation is to take yourself to the data, take yourself to the source of the problem, or take the best person to the problem. So that's what I did here. And the problem was that this was G Plastics. And we were building new plastics, and we needed to flame test it. And when you flame test plastics, you put the sample and bring a Bunsen burner below it and set it on fire, basically. And it warps in 3 dimensions, and you maintain that distance between the tip of the plastic sample and your burner as it catches flame. Then you time it in terms of how much time it took to catch the flame. Remove the Bunsen burner, bring it back again after the flame dies down. So you time how much time the flame took to die down. You bring the Bunsen burner back again and let it drip. So all of this was being done manually, and they wanted to automate it, and they've been trying for 15 years to automate it. And the way they were trying to do this was by subtracting the image of the flame from the sample. Very logical way of thinking about doing this. So when I took my colleague, his name is Anandraj Sengupta, to the problem, it wasn't very long. He saw the problem and he said, Gopi, there is no point in trying to subtract the flame from this image. What we need to do is track the shadow. Right? So if you think about it, the flame doesn't cast a shadow, and all you'll be left with is the plastic sample and the Bunsen burner. So you can make sure that the distance between the burner and the sample is fixed. And using that shadow, you can time everything with a video. Right? And this was very simple, and he repeated this again and again. Any problem that I took him to, he came at it with theoretical knowledge, very fundamental, and at the same time, a practical application, very useful. So that's what we engineers we did all the time. In this world of AI, in this world of constant technology change, the engineering that we do is not going to change, in that we have to still be creative, we have to still be able to deliver to the promise that we make. However, there are a few changes that we need to think about. One of it is when I was an engineer in the past, I could be a specialist and coast pretty much. I could be an electromagnetics sensor developer, and I could be that for the rest of my career. That's no longer going to be the case. Things are moving very fast. Materials are moving very fast. Life sciences and what's happening in life sciences are impacting every other area of engineering as well. And the computer sciences, including AI, is moving very fast. So it's not just about AI. AI has a role to play amidst all these other technologies which are developing so fast and so beautifully for human health and comfort. So being continuous learner as an engineer is very important, and that is the workforce which is coming into the companies, and that's what we are seeing. Engineers have to be storytellers and artists. This was always the case in a sense, but now it is very explicit. You need to sell your idea, you need to get funds, you need to let your idea flourish beyond the go, no-go decision of the first phase. All of this requires you to be able to tell a story, right, Yavande? Yeah. So we have many storytellers here, and you have to be an artist. You have to be able to think creatively. You have to be able to think creatively with freedom, and you have to be able to come up with solutions like I described. Anandraj Sen Gupta, the flame doesn't cast a shadow. The flame doesn't cast a shadow, but how do you translate that knowledge into something useful? Everybody knows deep relationships are going to be useful in your career. But let me tell you that as engineers, we need to nurture those weak ties. And it is those weak ties. In this room today, I'm making many weak ties. You know that you can reach out to me on a particular topic, and you know how to get hold of me through IET. And these weak ties allow us to collaborate across companies with academia, be able to pick up a phone and call and know whom to call for what to get done. But also it means that when somebody calls you, you answer the call and help complete that engineering process. So in engineering, definitely we need to think about those leverageable weak ties. As we move forward, engineers are realizing, and they're forcing all of us to think that we are custodians and not owners. If we are a manager, we are a custodian of the team. If we have funds, we are a custodian of that money. If we are in charge of a product development, we are still custodians. So we are not owners. And that is tied to the next, which is we are connected to the planet. We need to leave the planet better than what we inherited it. So these are things that are driving the new age of engineers. It's not that it was not with all of us, but it's even more specifically driving the new age of engineering. So in this context, then what is leadership? Leadership maps itself well to this as well. Leaders have to demonstrate that they are responsible. Leaders have to show that they have a vision which is beyond just making money for the company. Previously, it might not have been required. It was enough to say that we want to grow 10x in 10 years. That was a vision. It was never a vision, but leaders might have thought it was sufficient. Today, it is known that you cannot have visions which are only revolving around profits and losses. So you have to be responsible. Leaders, in turn, have to be creative and inspire creativity. Right? So if engineers are creative, you need to provide an venue, an avenue for them to be creative. And we have to think about the world hands-on. We have to look at the problems close. And the leaders have to be able to provide the opportunities to engineers to go to the source of the problem. Leaders have to be change agents. In the analog digital world, leaders have to understand that the world we are in is not just digital. We are in an analog digital world. And in this world, we have to reimagine everything in terms of, let's pick music. Today, if you're thinking about digital music, and that is the state of the art, can we think about bringing the analog, the live experience of music back into the living rooms? That would be creative. So digital has its advantages. Digital keeps the music and the notes intact because of the way it's coded as it goes through the distances that it has to travel. However, analog has the properties of creating a vibe environment in the room, which can be recreated if you use analog at the end point. And this is something that leaders have to be thinking about. And leaders have to ensure that they're thinking about being globally impactful. So engineering and engineering excellence is something that we have to look at in a broad context of ensuring that as we look at engineering, there is a strong engineering foundation, which includes theoretical fundamentals. I talked about it. I talked about Anandraj Sengupta. He knew that the flame doesn't cast a shadow. But also, you need that hands-on expertise to be able to take that fundamental knowledge and translate it into something that is useful. Engineering mindset, understanding the component, but also making sure that we understand the systems and thinking at a system level. And execution, understanding cost and productivity and being conscious about it, but also being able to document and collaborate not only with the future, but with the other engineers in the present, but also collaborating with yourself. If you look at your notes a few days after you have been in the depth of engineering a piece of work, you will be surprised. You will think that it is somebody else who has written those notes. And that's what I'm talking about, that even with yourself to collaborate, you need to be able to look at detailed documentation. So this is a foundation of engineering and engineering excellence. And then innovation. Innovation is about finding new ways to create value. So you create with freedom. You nurture with passion, and you change with detachment. These actions, create, nurture, and change, are uniquely associated with those mindsets. So why is it that you cannot create with passion? Because it's too early sometimes to bring in passion when you're still trying to figure out all the ideas. You're still open to all the ideas, not only your ideas, but ideas wherever they come from. So hence, these mindsets are uniquely associated. Create with freedom, nurture with passion, and change with detachment. So in a corporate setting or in an academic setting, these three aspects, create, nurture, and change, will remain. However, how you go about doing that will be unique to your companies, and we can talk about it. So for example, a flavor of creating is know your end customer. And that you can learn best from looking at FMCG companies. So if you look at Procter & Gamble, they send their people to live with the customer and know their end customer. So that's how they get creativity. The source of their creativity is their customers. And I'll give you an example. Procter & Gamble in 1990s were looking to target the China market, and they were looking at diapers. And the thought process and the marketing was very simple. China at that point of time also was very large, 1 billion plus. Now obviously there were many children, and so there is a need for diapers, and Western diapers in this case. And also they knew that China was a cost conscious market. So what they did in terms of market research was this: sitting in the US and doing market research for a region far away. So they decided that China needed cheaper diapers, so they went about making it. They made this diapers which were much lower cost, and they were a little plasticky but did the job. And then they released it into the market, and it didn't work, right? But Procter & Gamble then did what they really do well. They didn't pack their bags and leave. They sent their team to China, and the team spent time looking at the customer very closely, really closely, and they understood that Chinese used something called kai dang ku. Anybody from China here? Did I say it right? More or less. Yeah, kai dang ku are the Chinese diapers which has a hole right in the middle, and when the baby squats, the diaper doesn't get wet. So any of you who have been parents know that with Western diapers, the best attempts that you make, you will still have a diaper rash on the baby, right? So the Chinese were not very impressed with the Western diapers, so they wanted to use their own diapers, which did not result in a diaper rash. So at that point of time, the Procter & Gamble decided that let it be that we cannot target the daytime diaper, we'll target the nighttime diaper. So that's what they did. And they had to make a diaper which was more expensive because the diaper had to last longer. It had to last 8 hours versus 4 hours. And so they did that, and they created a diaper, released it into the market. But even before doing that, they had to think about brand and advertising. So they said that, look, nighttime, the Chinese diapers will still get wet because the baby is not squatting. And the baby will wake up, baby will cry. And one of the husband or wife has to get up and go and take care of the situation, right? And many marriages break in this process, determining who is the person who goes and takes care of this matter. And so they said that, look, your baby will sleep through, our diapers will absorb, the baby doesn't get wet, you will sleep better. And so they were very successful. By within a year of introduction of these diapers, 90% of the babies in Shanghai were wearing the Procter & Gamble diapers. So something like this is amazing. 90% is a large number. And they didn't stop there, just to make sure that you understand that there is no one-time success and that is it. That's a Harvard business case study, but life doesn't work like that. So they maintained their presence in the market. They understood the customer very well. And a few years later, they went with an advertising campaign saying that not only do you sleep well, they did some research with a Chinese university and said even the baby sleeps well and the baby's cognitive abilities increase. Right? So now who will not buy these diapers where the diapers enable the baby's cognitive abilities to increase? Right? So this is still a story of innovation where the source of innovation was actually going to the customer. I'll just spend time on one more story and we'll move in the interest of covering the material. The ability to shape the market is slightly different than understanding your customer. So Intel is a great example, was a great example, and hopefully they again regain that prominence of shaping the market. So what they did was they were able to predict the future. Moore's law, for example, the transistor density will double every 18 months. But that was the nature of the company. Otherwise, just imagine a chip maker decided how the computers were to be. It should have been the other way around. Right? The computer maker should have given the specifications for the chip maker. But that was not the case because Intel shaped the market, they understood the market, they made the market happen. So you go through these, and each company has a different way of being able to create. Similarly, each company has a different way to nurture. 3M, for example, the Post-it note, it was a failed adhesive. The reason for its success was because they talked about it. The person who made that adhesive spoke about it, and the person who needed such an adhesive for putting stickies on his choir book for weekend music at his church, and that's how the Post-it note was created. But the company took a bet on something like that and put money behind it. So that's all part of the nurturing aspect of innovation. And change is very difficult. When you're the most successful, can you change? And so that's where there are very few stories to tell, but one good one is Netflix. Netflix changed the market by introducing mail-in of CDs when there was a video library of tapes. But simultaneously, they started looking at sending content over the bandwidth which was hardly there. So just imagine a company, when you're talking about hardly bandwidth existing, they're already talking about sending OTT, over the top video streams. And so that's a great example of thinking about change. But these are old examples, but there are many new examples as well. Think about Airbnb or one of the many companies which are part of the sharing economy. Right, Uber, as an example, is part of the sharing economy. Airbnb, I would never have imagined that I would go and stay in somebody else's house or stay in somebody else's, not entire house, but only a bedroom where another bedroom is occupied by the landlord. But this is a reality now. I have done that. I've done it in every form just to get the experience of what is happening culturally. Culturally, that's a big shift. And anticipating something like this is again a way to think about creativity. So you can go on and on. Each company creates differently. I wanted to also just put up a roadmap of my career just to highlight a few things. That a career is never in a straight line. So many times you take a step down. As an example, as a lab manager for the GE John F. Welch Technology Center, my prior job was leading as VP of Technology 400 technologies in the US, but I wanted to be back in India. So I went to a role where there were 4 technologists and we started all over again. Right? So sometimes you take a step back only to run harder and jump longer. The other point I wanted to make was something like IET, volunteering. It doesn't happen at the end of your career, it happens throughout. And you don't have to separate out a career and volunteering, it's part of your career. So for me, throughout my career, be it in college or be it later in grad school or be it in my first place of work, I was always a volunteer and took great pride in the fact that I learned many of the leadership skills while volunteering. And skills you develop and you develop again. So you think about it, when you are in grad school, you develop the expertise, you develop the ability to create imagination. But as you move forward, you develop the ability to think clearly, you develop the ability to focus externally, you develop the ability to work inclusively with team members. Right? So these are things which will repeat all over again when you pick up a new job. Maybe each learning phase will accelerate, but this is a career map, this is one career map, and each one of you has a career map. As you share it with youngsters, I think it is important to emphasize how they should look at their careers and how they should spend time in a job, learning and becoming an expert, but also keeping in mind that in the era that we are in, continuous learning is important. So on that note, let me talk about artificial intelligence, something new, something all of you want to understand, something which nobody understands fully, but it's got applications that are really magical. Yeah, so neural networks, and this afternoon we had a talk, Ranjan Nag also presented and demystified neural networks, so I'll be doing a version of that. Neural networks, to first understand the artificial neural networks, so-called artificial neural networks, we first think about the biological neural networks. The human biological neural networks are very powerful. And why is it that they are so powerful? They are made up of a computing unit called a neuron. But a neuron in itself does the following. It accumulates inputs from other neurons and processes it through some nonlinearity and sends it onwards to other neurons. So is this what makes the neural network powerful biologically? And is this what we mimic and make the artificial neural network powerful as well? The answer is actually it is an element, but it is not the critical element. The critical element is the massive interconnectivity between neurons. And the intelligence that we have, the intelligence that is stored in an artificial neural network is stored in that massive interconnectivity. And that's very straightforward if you think about it from a standpoint of one of the messages that we need to give everyone is that there is nothing to worry about neural networks. It is mathematical, and what it does is it draws lines and surfaces. I made a statement, but that's the equation there. You might not be able to see it clearly, but a neuron, what it does is it does what is in that circle, which is ax plus by plus c equal to 0. Right? At the simplest level, that is equation for a line, and that line can separate out classes. So if I think about it in 2 dimensions, I can separate out cats and dogs, and I can separate out by drawing, let's say, the length of the tail on one axis and the pitch of the bark or the meow on the other axis, and I can use that to separate a cat from a dog. It's a very simple way of thinking about it. But that is the first layer. So in the first layer you draw a line. In the next layers you draw surfaces. Those surfaces can again separate out the classes. You can separate them out in multi-dimensional space, but also you can morph one surface to another. So I can take a face, Peter's face, and make it something else, and make him say something else, and something he would have never said. But it is possible in his voice. Some other face or some other voice in his face, and saying things which he didn't like, or saying things which he would like and somebody else is saying it. Everything is possible today, and it is very realistic, and some of my colleagues will show you examples of that as well. So what is happening? Why is there so much excitement about neural networks? And this is mostly because of the computational power that we have at our disposal today. What we did in 1990s and Ranjan did in 1980s using multi-layer perceptrons and neural networks is not much different than what is happening today. A deep neural network is a multi-layer perceptron. We use 3 layers. Right now you use any number of layers. Like I said, if I use 3 layers, by the time you get to the second layer, I get a surface. And those surfaces can be in multi-dimensional space. And so all the tasks I needed to get done, I could get done with 3 layers. So why would I go for more layers? For more accuracies, for more granularity on certain features that I want to look at. But we didn't do that. We did it in a manner which was computationally sensitive, because we didn't have the computation. Today you use as many layers as you want. But also there is something called convolution neural network, which you put to pre-process data. And what it is an ability to automatically extract features that it needs. So if previously I was looking at an image, I would not feed the image to a neural network because it was going to be computationally intensive. And so the computer would just crash. Forget videos. I would not feed an image into the neural network. What we would do with the neural networks is use discrete cosine transforms and use the top few discrete cosine transforms and say this represents the image. And it did for most purposes, but we would lose maybe the finer details. If I had a crack in a tube, it might not get caught by the discrete cosine transform. So today, by using the convolution neural networks, we are able to look at the image in multiple levels of granularity. I can look at the shapes, I can look at the lines, I can look at the colors at various levels of granularity as it passes through the convolution neural network. And essentially what it is doing is understanding the image, the way we did it with discrete cosine transforms. And then it goes on to a fully connected deep neural network. So that's the core of all AI that you know today, is a deep neural network. So you think about a transformer, which is the center of a large language model. It has 2 deep neural networks. You think about stable diffusion, which is used for all the images being generated. Again, it has deep neural networks as part of the core of the technology. So this is what all the excitement is about, the deep neural networks, the convolution neural networks, and the ability to take them into a transformer. The transformer networks are based on a paper called Attention is All That You Need. It uses 2 neural networks to get to that attention. What it means is that a word is not as important as the context that it is in, and that context is obtained by attention it places on all the other words across multiple texts as they associate with this word. And that's how ChatGPT works today. So that is the excitement. And where are the applications? The applications, again, today the excitement is in the fact that I can do natural language processing. Natural language processing is not just looking at words, not looking at phrases, looking at meaningful output in terms of poetry, in terms of proposals, in terms of abstracts, given some inputs. Voice recognition, very easily done today. So it's used as a biometric. So you can use AI for voice recognition. Image recognition. So there is a database which we were using even 3 years ago. based on 3 million images. And this database, what it did was it also had a trained neural network behind it, and we could use the neural network straight away. But you're not interested in those 3 million images alone. So the way you used it is you chopped off the classification layer, and then the layer before that became a signature for anybody's face. So I could take one image of, let's say, my car and pass it through the network. I get a signature for my car, and then I can recognize my car based on that one image forever. As he disguises himself, grows a mustache, or ages, or looks younger, whatever it might be, I can still recognize my car the way the network has been trained. So it's a very robust way of looking at image recognition. As we go into the future, images are going to be easy to do, so we go into video. We are going to do readily voice recognition, so we are going to be able to do voice matching. So I can have the voice, let's say today I need to produce a movie, I need a celebrity to act, I need the celebrity also to record the voice, dubbing. But I don't need so in the future. Actually today I can do it. I can take anybody's voice, do the dubbing and make it match the celebrity's voice. Of course, I can also match the celebrity's face, but that is a little more nuanced. And of course, digital employees people fear. So if you can work with the CFO, Ed, if you can work with the CFO, I don't know where Simon is sitting there, who is digital and has all the knowledge of what is required in the financial world, and also talks to you in a pleasant manner and smiles, and even if not granting what you need, says it in a nice way, Simon is going to get worried. Right? So today it is possible to do this, digital employees for knowledge workers. But really, I would like to go and talk to Simon. And I'm sure that there are many who will continue to want to talk to a person. Just like today, to book a ticket, most of us do not talk to a human being. We just go through a system and get an airline ticket. Previously, in a corporate setting, we would go to the individual, sit down and plan the trip, especially if it's a global trip. But let me also make another statement about AI. AI will not cause jobs to be lost. AI will create jobs. In fact, in India, I've called for creating 100 million new jobs. Right? That's a lot of jobs. How do you think that's going to happen? It's going to happen because we're going to make jobs more accessible in remote corners of the world. And we're going to redefine jobs. Jobs don't have to be 8 to 5, working 8-hour days and working 5 days a week. And working in the office. It's already happening. So jobs are going to be very different, and in that environment, somebody who is not doing anything, for them to work, let's say 2 days or 2 hours a day, that becomes a job. So these are all going to be things which happen in the near future, and it's good. And those who continuously learn will always have things to do, and much better things to do, because the rote aspects of their jobs will get taken away. Give you a few quick examples and wrap up, and call on my other speakers to give you more flavors. So here are a few examples. So real-time object detection in an inspection setting, very engineering oriented, an aerospace component, and you want to inspect it. Today, if you want to do it, you need a trained ASNT level 3, which is an American system, person doing this inspection. You're doing it with various techniques, but this is fluorescent penetrant inspection. So you dip the particle in fluorescent liquid, take it out, wash it, and then you examine it manually. Right? You can automate this completely, but here we are showing a semi-automated system where a camera is replacing the eye, and the AI part is replacing the intelligence. So you're looking at the fluorescent reflections and determining if there are defects or not. So all reflections are not fluorescent, and all fluorescent reflections are not defects. Some of them are geometric, some of them are reflections because of geometry. So all of that intelligence is programmed in. And also the fact that a camera can look and get that reflection is also AI programmed in. So this is one example of what you can do with AI and what is being done today. And these examples which I'm sharing are all from what we do as a team, so first-hand information. So here's another example, nighttime video. And if it's a rear parking camera, and you're trying to park, it's very difficult to see in this scenario. Even if you use IR, infrared, the nature of the images are not going to be very conducive to parking. So we have taken that nighttime video and made it look like daytime. And you can see the ability to park definitely increases, but also everything else is much more visible. So if you're using it for surveillance, you can do it much better also. So some of you are probably signal processing folks and video processing folks. You can do some element of this using filters, but if you use filters, you know that everything will get uniformly brightened up or darkened down. So it's not going to work the way this has worked. Here's another example of what can be done. These are Delhi streets, and so the problem was that object detection was done globally, but on Delhi streets you also have cows and horses and various other things which the local people felt that the global scenario was not sufficient, and if you had 2 people walking on a street in Delhi streets, you have thousands of people walking in the street in a small distance. So the problem becomes very different, the scale becomes very different. So this again is something that the AI can do very well. Now hence that brings us to the question about ethics in AI and ethics in data. So are we doing things correctly with data? Are we doing things fairly with data? Fair doesn't mean just privacy. Fair also means, are we paying for the data in a fair manner? And are we looking at the impact of AI and ensuring that it's not being used to discriminate? For example, I can easily differentiate ethnicities, but we as engineers should ensure that we are not allowing it to be leveraged for discrimination. So those are all things that are going to form part of the discussions going forward. We were part of the Safe AI conference which UK did, and we were also able to comment on Biden's executive order on AI just before the conference. So as IET, we do have inputs in these matters. Now into healthcare, there are various ways you can think about healthcare. I'll be covering that later as well. So to keep it short, can you look at wearable data? Can you look at non-invasive wearable data and determine chronic inflammation, which is a precursor to chronic diseases, and every disease other than infectious disease is a chronic disease. If you are able to do that, that is quite something, and we have at least shown in a proof of concept way that using bioimpedance and using heart rate variability and using certain images of the face, you will be able to determine whether the individual has a trend which is increasing the inflammation. So this is cellular level inflammation that we are talking about. So when you think about AI, you need to think about it and use it in a manner that's just not replacing some existing way of doing it, but think about a new way of doing healthcare in this case, right? So resilient futures, and this is going to be a topic of a discussion in COP28 as well, and we will be representing IET there. The thought process is, as the world's population grows and as we find more and more technology and more ways to provide human health and comfort, who is talking for the planet, who is thinking about the planet, and who is thinking about our own future into the several years later, and who is thinking about other species which exist on this planet. So to deliver for resilient futures, one way of thinking about it is that we need to, as companies, as individuals, as organizations like IET, track the trends, socio-political trends and the consumer trends, and be able to map them into market needs and serve them better using technologies which are not just AI. And like I said, it is going to be an intersection of technologies, computing technologies and AI being critical there. But life sciences, you have all the omics, you have the genomics, connectomics, transcriptomics, and so on. And then you have the material sciences. Graphene as a material has wonderful properties, can deliver things in a more efficient way. It has 100 times the strength of steel by volume and 10 times the thermal conductivity of metal. So these are properties that can be leveraged. So you can combine these technologies and at that intersection recreate everything that is out there to be more environmentally friendly. And this looks in a detailed slide in this manner. So you think about biology, you think about digital, you think about materials, and you combine some aspects of these emerging sciences and emerging technologies into strategies for the companies as we move from looking at affordable renewable energy to net zero, to near zero carbon, and from moving from diagnose and cure in healthcare to predict and prevent, moving from mobility to virtual presence. All of these are going to impact positively and create a resilient future. So with that, I'll end saying that the world is changing rapidly. We are up to the task. Engineers will make a difference. Create with freedom, nurture with passion, and change with detachment. Thank you, ladies and gentlemen.
I have to say that working in media and entertainment has its perks. I tend to binge watch actually shows on Netflix and Prime Video and pass it off as research. Sorry, Gopi. But for me, it really started with looking at the evolution that we've seen AI as a technology take. In fact, it started with a very familiar sort of evolution if you compare it with other technology transformations from the past. Human beings create a technology, then they start to become consumers of that technology as it starts to gain widespread acceptance. But for some technology disruptors, including AI, they have now gone on to become augmenters of human activities, creating outcomes that are faster, cheaper, better. But I believe that we are at a stage in this evolution where AI is starting to break from the past and really become more of co-creators and collaborators for many human endeavors, including our daily activities. And a lot of the recent advances in generative AI has enabled this transformation. And this is particularly relevant for the media and entertainment sector. And I'm going to start off with content, which is really at the heart of this world. But AI for content creation is a bit of a controversial topic of late. And we hear this constant refrain of how AI will take away jobs and make it difficult for everyone, and there's understandably a lot of fear around that. But I think there's less attention that's being paid to applications and use cases where AI can enable outcomes that would have previously been not possible due to constraints of time, cost, and sometimes even human capabilities. Here is an example of an AI model that is able to transform content to make it suitable for global audiences. Now, one of the big challenges with dubbing in video is that there's a constant mismatch between the video and audio.
These models learn from training data to produce new data with similar characteristics.
L'IA générative, également appelée Genet, peut créer du texte, des images et d'autres médias grâce à des modèles génératifs. Ces modèles apprennent à partir de données d'entraînement pour produire de nouvelles données similaires.
Generative künstliche Intelligenz, auch als GNI bekannt, kann Text, Bilder und andere Medien mit Hilfe generativer Modelle erstellen. Diese Modelle lernen aus Trainingsdaten, um neue Daten mit ähnlichen Eigenschaften zu generieren.
जेनरेटिव एआई, जिसे जेनएआई के नाम से भी जाना जाता है, जेनरेटिव मॉडल का उपयोग करके टेक्स्ट, चित्र और अन्य मीडिया बना सकता है। ये मॉडल समान विशेषताओं वाले नए डेटा का उत्पादन करने के लिए प्रशिक्षण डेटा से सीखते हैं।
Now, there's a couple of different AI models that have been stacked together to generate these outputs. The first model transcribes the original audio to text. Another model translates it from one language to another. And then there's another model that generates audio out of that translated text. And finally, there is a video transformation model, which changes the original video to match the new audio. The space of content distribution has already seen tremendous changes in the last decade or so, particularly with the rise of digital distribution channels and video streaming. But what this has meant is that there's a tremendous strain on the existing infrastructure, particularly on network and bandwidth. Here is an AI model that is able to transform low resolution, low bitrate content, which you see on the left, to higher resolution, high quality video. What this allows streaming service providers to do is they can stream lower resolution and lower file size of videos, thereby reducing bandwidth requirements, while the AI model is able to deliver high quality content to viewers. And lastly, which is I think the most important part of the media and entertainment space, which is content monetization. Content monetization really starts with generating deep insights about content. Here is an AI model that automatically identifies many different components of a video: people, actions, sentiments, objects, and context, and is able to automatically generate a text description. Now, this ability to generate rich metadata about both video and audio is then able to enhance existing monetization models, whether that's for intelligently inserting ads that are contextual, based on content and user personalized, and create deep and rich content discovery options, the ability to interact with content, as well as create highly personalized recommendation models. So that begs the question, what is the future of entertainment? What will that look like? I think we can all safely agree that the days when families used to gather around the living room and watch scheduled programming on TV are a thing of the past. Today, content is on demand, and it is on personal devices, and it is highly individualized. And a lot of these changes have actually been brought about by AI models, whether that's for content discovery or recommendation models, or for the type of generative AI that we saw earlier that is able to transform content to make it suitable for many diverse audiences. That brings us to the next point. Today, content is necessarily global. And it's not just about globalizing content. There is a need to culturalize content, which means to take into account cultural nuances of different types of audiences in different parts of the world. And AI plays a critical role here as well, whether that's for tasks like transcribing, translation, and dubbing, which we saw earlier, or for transforming content in very different ways, including for content moderation. And lastly, content consumption is not passive. There is an increasing demand for interactive and immersive entertainment. AI, with the conjunction of different technologies such as AR and VR, are able to create rich, incredibly realistic and immersive worlds, whether that's for gaming or CGI or for animation content. So, in essence, this rapid transformation that we're seeing in the media and entertainment space is happening as we speak, and AI is at the heart and center of it. And I, for one, am excited and optimistic about the role that AI will play in continuing to reshape the space. Thank you.
I'm just going to have a quick canter through a few of the ways in which AI is impacting the automotive industry and give you a few thoughts around that. One of the areas where we've already seen an amazing impact is in engineering component design. With generative AI and with additive manufacturing, it's now possible to produce components that are completely unlike anything that an individual draftsman would have put together in the past. We're looking here at a seatbelt mounting bracket assembly. It would have been an assembly. It would have used 8 different components. But what's been created over here looks more like something that's grown inside an animal or a plant. But the end result is that it's a single component doing the job of 8. It's 40% lighter and 20% stronger. And it's got nothing whatsoever to do with traditional drafting or traditional metal bashing. It's a complete change. At the heart of automotive is, of course, the styling of vehicles. It's a really important thing. And generating the style for a vehicle is something that's really difficult to do. There are thousands of constraints that actually impact on how all of the 3D surfaces of a vehicle work together. And traditionally, that's taken whole departments to do that, to get from 2D sketches to full 3D surfaces that are fully feasible to manufacture. But in fact now, AI, utilising that level of information, can do that pretty much at the click of a button. And that's in itself effectively eliminating whole swathes of human activity necessary to do that. A big, big change. And of course, once you've got a lot of data that's describing what a vehicle's really about and what it looks like, AI is now able to pick up all of that and to produce digital twins that are an incredibly accurate representation of the vehicle. So, for instance, customers can look at the vehicle, they can see it in different environments, they can see the combination of all the different options, and that can be done directly from the data. In the past, that's required assembling dozens and dozens of different prototype assemblies, photographing them under different lighting conditions and so on. But now that's coming directly from the data. A big, big change and a huge improvement in the efficiency of that process. And digital twins are also playing their part in the design of factories and in the design of the manufacturing process. BMW themselves have now produced digital twins of all their factories. And what that enables us to do now is to actually work on the way that production processes work, use virtual reality and simulation to understand the ergonomics of all the processes. So without having to construct a real factory or change a real production line, you can really understand how people are going to be able to interact with it and how it's going to work. A huge improvement. Test data analysis is something quite dear to my heart. I've done a lot of work in control systems design and so on, and it's always been a huge challenge as to how much can you measure? Can you actually use all the data that you get? Can you drag together data from all sorts of different tests? Well, now that's amazingly been tackled again by AI. We're at the situation now where you can actually take a lot of different data files and put some commands into ChatGPT and ask it to tell you about that data. What have you got? And it'll generate Python scripts, and out of those Python scripts that it'll run automatically, it'll give you real insights into the data. And that's just such a huge game changer, actually being able to use all the data, actually being able to access it all. And one of the biggest places that becomes really important is in autonomous vehicle test and validation. The scope of the functionality in autonomous driving is enormous, and the number of possible test cases is sort of almost infinite. So to try and test and validate in the real world is just about impossible. But with a digital twin environment that can now be generated directly from test data, and then manipulated to change the scenarios, add different weather conditions, turn what was a dry environment into a snowy environment, add actors like bulls bouncing out into roads, children running after them. It's possible to do that validation. And that's the key to really making it possible to develop autonomous driving systems. And autonomous driving is actually really important. A lot of people just aren't aware that about 3,500 people die on the roads worldwide every year, and pretty much all of that's down to human error. So the advent of autonomous driving and the functionality around it's got a real prospect of doing something to reduce that and reduce the hundreds of billions of dollars of costs that are associated with it. So that's a real big benefit that we can see coming down the road. Whether or not we'll actually get to the point of having a benevolent AI operating the whole world for us, well, it's probably a bit early for that right now. But certainly AI-guided management decision-making is on the cards. We've already got AIs deciding who should be hired and who should be fired. But there's a real prospect, I think, that we might do away with some of the ego-driven decision-making that actually interferes a lot with the engineering job and end up having better-run companies that make more use of their engineers. And who knows, one day we might even do away with the need for expensive CEOs and replace them with AI. Okay, thank you very much. Now,
I'm going to talk very little about AI. This evening we were asked the question, how can engineering and AI contribute to a resilient future? And I guess I come with a question, resilient to what? Which I think hopefully complements the excellent talks we've heard so far. The government published its resilience framework at the end of last year, and if there's two things I'd draw out from it for this audience, it's two things. One is it drew a really important distinction between acute risks, things that might happen in a moment, and risks which are chronic, which play out over time. And the second thing I'd draw attention to is the need for that for our understanding of those things and those risks to be informed by foresight. So I was delighted to see that in the resilience framework. My job is to run the government's foresight unit in the Government Office for Science, and we exist exclusively to help government think in a kind of structured and kind of coherent way around future challenges and opportunities. So we're obviously very delighted to see that. And I thought, actually, Gopi, something you said this evening about Intel predicting the future drew to mind someone who I'm sure is very familiar to this audience, Dennis Gabor, and my favourite quote of his, it's impossible to predict the future, but we can invent futures. And that's something that we take really closely to heart in our work in Foresight, is that sense that you can think in a structured way about the future and what bits of it that you like and how you might get there. And I think that's an important aspect to bring to how we think about risk and how we think about AI. What future do we want? And what's the role that AI can play in kind of contributing to that? So as you'd imagine from a function that exists like mine, we are thinking very deeply around those kind of chronic risks and how that might play out in future and how we can help government to understand those. So what are some examples of chronic risks? Something like serious organised crime or antimicrobial resistance. It doesn't act in a single moment. It isn't a moment of emergency, but over time it steadily erodes our ability to deal with the risk or steadily erodes our ability to perform functions. So that's kind of how we think about chronic risks. In other parts of Go Science's work on the future, you can imagine some other things that might kind of meet that definition. Population ageing, climate change, issues like that. So there's a few important things that I think that we need to consider when we're thinking about something like a chronic risk. And the first is that those kind of connections between those chronic risks and each other, and the chronic risks and acute risks, and how they might play out to change the national risk picture and change what we want to be resilient to, and how AI could help. So to give you an example, obvious one, climate change will make a big difference to things like wildfires, acute risk. Population aging, in a world where we've had maybe another 20 years worth of population aging, risks like pandemic flu start to look very different from what they might do today. So you can start to see some of those interconnections. Another thing that I think is important is that many chronic risks aren't going to act linearly, and they may be very uncertain. So demographics, relatively there's a famous quote, demographics is destiny. It's hard to magic up 80-year-olds out of nowhere. They tend to have been born about 80 years ago. So we've got a relatively good sense of kind of where our demographics are going. But other areas of chronic risk are much, much more uncertain. So we need to think about different endpoints, different ways those could pan out. We know that the global population and the UK population, for example, is going to age relatively significantly. We don't know how much progress we're going to make around things like health expectancies and how healthy we are as a population. So we need to think about multiple different scenarios for these chronic risks and how they interact. So what does all that mean for AI? I think there's three things I'd kind of draw out. Coming right back to kind of what we're meant to be talking about, sorry. First thing is, AI is, as we've heard tonight, a massive change. It may not replace all kind of many, many jobs, but it's certainly going to disrupt a lot of them. And AI will bring risks with it. So what are the I guess one question is, can we think of AI as a chronic risk? What are the changes and the slow burn changes or the faster changes it's going to bring to us that it's going to change what we want to be resilient to? You've heard an awful lot from the UK government about how it's getting ahead of some of the kind of big AI risk questions and the AI Safety Summit. Our contribution to that was some scenarios that we published and a risk assessment paper around future AI risks in the run-up to the summit. And we'll be doing more work in that kind of space through the Foresight program shortly. But one area where I think we need to think about is that kind of AI as a kind of question in the kind of that risk space and potentially as a chronic risk, it's kind of slow burn change. The second, I think, is that, as we've heard tonight again, AI is going to play an important role in helping us respond to many of those risks. It will have a huge role to play in how we respond to climate change, minimize our emissions. So AI both as a risk, but also as an ability to manage risks. And maybe a third, I'd say, is thinking about that uncertainty, those interconnections, and how those different types of chronic risks, acute risks, can interact with each other. AI is one of those tools that helps us to spot patterns that we couldn't see, interrogate larger data sets, and kind of really kind of get through some of the complexity that it maybe holds us back from some of these big systemic challenges. I'm really excited about the potential for AI in that space to help us to improve science, to improve our understanding of how we kind of respond to some of these kind of slow burn chronic risks or kind of systemic challenges. So I'll end there on a kind of hopeful note that I think as we develop our understanding of systemic risks and chronic risks, AI could be very much part of the solution to that. And with that, I think I'll hand back to Gopi.
The question is, as we move forward, are we hackable? Do we know enough about the human body that makes us hackable to understand us to a point where we can intervene as required and make us perform as we want to perform? And the answer is we are not yet there, but our understanding of the human body is at an all-time high, as it should be, and the ability to take AI into that understanding is also significant. So if you look at diagnose and cure to predict and prevent, moving from organ and tissue health to cellular health and then to molecular health is how we think about it. Organ and tissue health is where we have been. And when we look at a CT machine, a MR machine or ECG machine, what we are looking for is the health of an organ. Either it's vital information which is coming out through an ECG machine or a tumor that we are detecting using a CT or MR machine. Many of us have not thought through and understood what is cellular health. Cellular health is the health of every individual cell. So if your cell is healthy, then there is a particular ratio of water inside and outside the cell, that is intracellular water and extracellular water. That ratio gets disrupted, means your cell is inflamed. If your cell is inflamed, eventually it leads to your chronic inflammation and chronic disease. So that's another place where now we can play a role with AI. But also you have heard about omics and the various advances over there, and I mentioned it before, the connectomics, which everybody knows genomics, which is about the DNA. But connectomics is how the nervous system is connected, and that plays a significant role in both physical and mental health as well. But then there is transcriptomics, which has got to do with the RNA and so on and so forth. The gut microbiome and the microbiomics is another area of rapid advances. So with all this in place, we have to look at health in multiple zones. AI in diagnostics in going, like I said, into the organ health. There are many tools and we recognize those. For example, using X-rays to differentiate between pneumonia and COVID, AI was used. And then the MR output. MR is already a complex mathematical output from a piece of equipment which is really miraculous. But on top of that, if you add AI, you can get even better images. And then there is the ECG and the ability to automatically detect certain issues with the heart. Again, AI has been used in these areas. And then talking about moving from organ and tissue health to cellular health, I already mentioned about it before, but this is a context in a different setting, is that when we are looking at cellular health, we are looking at an ability to look at the cells being inflamed. Today, you have to do it with a blood test, and even that is a proxy. So if you're using a proxy, as well can we use a non-invasive proxy, and that is a Quest, and that requires sensor data but also AI, because we are combining information from multiple sensors. So if you just take bioimpedance, just take heart rate variability, or just take a flushed face, you're not going to get to chronic inflammation. So the ability to combine information is where AI plays a role. And with omics as well, looking at your data and being able to predict your day and how best you can look at your health at a molecular level is something that AI can play a role in addition to getting information from your body. So again, thinking about AI in healthcare means we need to think about it differently than just saying, can I detect a tumor automatically instead of a doctor having to detect a tumor. But you have to think about chronic inflammation and cellular level health. You need to think about molecular information and molecular level health. That is where AI is taking us, and so that is enjoying being in the moment. So while we say we are chasing bliss, enjoying being in the moment, living a full life while we are chasing immortality, and being human while we are chasing divinity. Right? So this is where AI is taking us. Thank you. Thank you.
So, anybody in the audience got a question? If you put your hand up, we've got one there and one here. We'll get some microphones over to you. I'm just going to go quickly to the questions we've got coming in from outside first, and then we'll come to those. So, Anusha, this one's for you. From deep fakes of celebrities to subliminal messages in landscapes, AI-generated media content is spreading virally every day. What responsibility should the developers of these tools take for its use or abuse?
I think there's not enough rules and regulations around use of digital data, especially images and videos. There's not enough information, there's not enough guidelines and framework on how they can be used, leave alone how they can be modified. So I think we have to start there, and I think the guidelines and the framework for modification of digital content has to be derived from ownership of content and how that can be viewed. So I think that's probably the most important thing. And I think we will also see a rise in the number of tools, and we're seeing that already in identifying digitally modified content. So I think there's going to be enough research in that space as well.
Brilliant, thank you. Have we got our first one from the audience? There we go.
Hello, right, Will Stewart. A lot of medical conditions that are mentally based are enormously helped by talking therapies. Now, I know there are some experiments in using AI to provide somebody to talk to, not cheating, being honest about the fact that it is a machine. I wonder whether that is the thing that actually is going to have the biggest impact in the medical area in the next 10 years. What do you think?
Brilliant, thank you.
So you're asking the question about matching a medical mental wellness practitioner to a patient. Yeah, I think that's a good use of AI to look at the needs of the patient and try to find the right expert to be able to talk to. But there are other aspects also, like proactively looking at the mind space, and there are tools which when you're going in for a therapy session, you want to meet a real doctor, but there are meditation sessions which can be well conducted by technology. So I think you're absolutely right. Mental wellness is an area which has not got much attention, and that's an area where AI can play a significant role. Thank you.
We've got one here now for Tom. What are your views on implementing an international regulatory approach in the UK which can promote innovation in AI, but at the same time minimise risks of safety and security?
Yeah, so in the scenarios that we produced in the run-up to the summit, one of the dimensions that we purposely varied was geopolitical cooperation on AI. And that was for one really good reason, is that if you're seeing increasingly these tools released on the internet, they're not going to respect borders. Any kind of regulatory approach which just takes a kind of a single country, where that model could just be then developed elsewhere, kind of deployed elsewhere, and then kind of used and then come back into a given jurisdiction, is going to be much more limited than a kind of a global approach. So I think different countries are going to take different approaches. There are obviously quite big cultural differences in terms of how we think about different aspects of AI and kind of privacy and copyright law, and lots of different aspects to that. But fundamentally, if we aren't able to take some kind of coordinated approach across the world, it's going to be much harder to manage some of the risks associated with AI. And I think that's why you've seen the kind of UK government convening the AI summit as it did.
We had another one from the audience, I think, right at the back there. Have you got your microphone there?
Can AI develop a conscience?
Gopi, we'll start with you on that one.
Yeah, I think it's difficult to define conscience. So the straight answer is no. The way you think about AI is it's programmed, it learns, but definitely it doesn't have a conscience. Yeah.
I've got a question now for you. Thank you, Gopi. We've got a question here for you, Torquil. We've seen lots of tech over the years start life in the automotive industry, especially from F1, moving really into kind of the wider audience. Will that continue, and do you think automotive AI will become something that then goes into other areas of vehicles, like motorbikes, bikes, and other areas?
I don't really see automotive as being at the forefront of AI as such. It has lots of applications within the engineering of vehicles, and a lot of it's actually applied to the way that vehicles are working and the user interfaces to them. And I think a lot of what develops there does spread out naturally, but I don't really see the automotive industry as leading in respect of, for example, consumer electronics, which is always going to be sort of several steps ahead.
Brilliant. Gopi, we've got another one here for you. Do you see any opportunities to use AI to remove inequalities in society for like life expectancy going forward into the future?
Wow. So AI has an ability to look at inequality in certain ways. For example, if you look at bias, there's a lot of worry about AI and bias, but it's easier to remove bias from data and hence AI rather than human beings. It will take longer. Now, in terms of inequality of life expectancy, there is much more than AI. AI should not be ever looked at as one silver bullet and it can solve a life expectancy problem. It's much more complex. It needs a systematic view in terms of solving that, but AI will have a role to play.
And just there's a sort of supplementary question here that came in, which was, do you see AI helping with our sort of global goals on net zero? Is that something that you think AI is going to help with as well?
That I think absolutely and necessarily. So I'll give a little detailed explanation. So if you look at net zero, there are many aspects. One is the aspect of being able to consume less. The other is the aspect of being able to produce in a more friendly manner with lower emissions. And the third is to be able to remove some of those emissions in a manner that is acceptable scientifically. And in each one of these areas, AI will play a role. I'll just give a quick example in one of the areas. So you can produce electricity much more efficiently by optimizing a farm of wind turbines rather than an individual wind turbine. So one turbine can actually let the wind pass so that two other turbines can produce better at the farm level, and that determination can be done using AI.
Brilliant. Have we got any more from, got one here and one over there, if you can get a microphone there. And there's Peter here in the front row.
My question is about training, development and mentoring. So how do we make careers in AI accessible, and how do we bring on young people into this space? And then supplementary question is looking at how do like establish businesses that have that are just traditional ways of thinking about the world. How do we help them step into this space?
Yeah,
brilliant. I think we can go through all those. I'm going to quickly throw in a little bit on the end of that, because you've asked 3/4 of a question somebody's posted in there, which as well is how do we get social responsibility aspects into the use of AI and the development of it as well from younger people?
Yeah. So we can start with you, I think, Tom. There's a question around how do we get more people involved, trained, and have AI accessible, and then I can...
Well, there's obviously a skills question to that, right? Kind of and it comes back to the inequality question as well. You know, if you don't have skills in the economy in kind of the right areas, then either companies that don't have those, or communities that struggle with those, or countries that struggle with those are going to that has a potential to exacerbate existing inequalities. There's a question for me around tutelage, actually, where if we're seeing AI predominantly having an impact on kind of quite process-heavy jobs or entry-level jobs where you're kind of maybe doing something a little bit more repetitively and using that to learn, then I kind of a little bit worry about kind of entry-level jobs and what happens there. And I completely accept the point that technologies traditionally have created more jobs than they've got rid of, which I think is your point. But I'm kind of interested in kind of how do we make sure that people still have that kind of ability to kind of join and develop that experience, which allows them to then be really good supervisors of AI. So that's for me is a big question.
So if I can add to that, to the jobs and skills aspect, there is going to be 70% of the jobs created which are going to be data annotation and data creation. And this is going to make AI kind of jobs at the data end available in remote corners of the world, including in areas such as United Kingdom, to be able to provide jobs in various corners of United Kingdom. 70% of the jobs will be, are we able to get the right kind of data? Because that is 80% of AI is about the data. 20% of the jobs will be about being able to take existing algorithms and being able to make them specific to a need of an industry or of a government or of wherever, and that will be urban jobs typically. And so to be able to get people trained into that requires little more forethought in the university, in the school system, and from institutions like IET to be able to provide that knowledge and skilling. And 10% of the jobs will be building new algorithms and creating new possibilities, and that will happen in the academic world.
Brilliant. Peter, I'm going to come to you next.
My question is not a technical question, though. Mine is one that's, I mean, so inspiring. I believe you're our first international president. So huge congratulations on being IT's first international president. You know, that's really inspiring for us all. Mine is actually a human question, and it's about Gopi, the president, and how you see the year ahead as our president. Could you say something about that, please?
Yeah, thanks, Peter. I think the role of the president is to, number one, ensure that there is a continuity in this 150-year-old organization, that we are ensuring that the tasks undertaken and the focus undertaken by the previous presidents remain. And hence, it is my privilege to continue talking about mentoring as we go into the next year. And mentoring of AI could be one flavor for that. But for me, the focus that I can bring with my background and skills is in AI. And fortunately, AI is under the microscope right now in many ways, including safe AI. So the ability of IET to bring neutral viewpoint on data ethics and AI ethics. These are two different things, even though there are overlaps. Data ethics is looking at the data we are collecting into training the neural networks and making sure that we are doing that in an ethical way in many different facets. And then there is the impact of AI and making sure that we are thinking through that aspect as well. And the critical thing for IET to do is bring that discussion into the engineering fold, because we are the best people to be able to do it. And then it can go to the policy fold. Tom, I'm sure you'll agree, because then we have thought through the details the way then policy can take forward. Thank you.
Before we go into our last question, we've got time for one more. I just wanted to say a huge thank you to Rachel Dance. I mean, an absolutely fantastic performance. She signed the whole show, start to finish, stood up, hasn't had a seat, and it will be online. So the actual live broadcast today was signed, and for you here in the audience. Let's have another round of applause for Rachel. Gopi, our last question. You've got a year ahead as the president of the IET. If you could change something that would make us the centre of excellence in AI, what would we need to change at the IET to really get us at the forefront of being the institution known for it?
Yeah, I think taking more risks and putting out greater challenges, and we are able to do that. For example, I called out for 100 million jobs being created in India, and that is possible. We need to make such calls, stand behind it, put details, so take greater risks.
Brilliant. Well, that brings us to the end. Gopi, you're going to have a few words before we go, I believe. But ladies and gentlemen, before we do, let's have a big round of applause for everybody who spoke today.
So ladies and gentlemen, thank you for being here today and making it also very interactive. It's my privilege to be the president of the Institution of Engineering and Technology for this year. My focus will be AI, but like I said, I provide a continuity to this wonderful 150-year-old organization along with all of you. Thank you.